So today's presentation will be over the structure of atoms and the trends of the periodic table presented by Miranda Weber. The theories. The first theory is the atomic theory. Each element is composed of tiny indestructible particles called atoms. All atoms of a given element have the same mass and other properties that distinguish them from atoms of other elements. Atoms combined in simple whole number ratios to form compounds. Atoms of one element cannot change into atoms of another element. In a chemical reaction, atoms only change the way that they are bound together with other atoms. These are the rules to the atomic theory. Now the nuclear theory. Most of the atom's mass and all of its positive charge are contained in a small core called the nucleus. Most of the volume of the atom is empty space, throughout which tiny negatively charged electrons are dispersed. There are as many negatively charged electrons outside the nucleus as there are positively charged particles within the nucleus, so that the atom is electrically neutral. And these are the rules to the nuclear theory. Subatomic particles of an atom. All atoms are composed of subatomic particles, protons, neutrons, and electrons. Protons and neutrons have nearly identical masses. The mass of a proton or neutron is measured in an atomic mass unit, AMU. One proton or neutron is approximately 1 AMU. And here is the picture of an atom. Here, the positive charged ions shown here are the protons, and these neutral particles are the neutrons, and the positive are the protons. And then these negative electrical particles are called the electrons, and an electron cloud. A proton and an electron have an electrical charge. Electron has a charge of negative 1.6 times 10 to the negative 19th, and a proton has 1.6 times 10 to the negative 19th. In atomic units, an electron is assigned a charge of negative 1 and a proton of positive 1. The charge of the proton and the electron are equal in magnitude but opposite in sign, so that when the two particles are paired, the charge sum to 0. The neutron has no charge. Matter is usually charged neutral. It has no overall charge because protons and electrons are normally present in equal numbers. When matter does acquire charge imbalances, they usually equalize quickly, often in dramatic ways. Elements defined by their numbers of protons. The most important number to the identity of an atom is the number of protons in its nucleus. The number of protons defines the element. The number of protons in an atom's nucleus is its atomic number and is given the symbol Z. In the periodic table, the elements are arranged so that those with similar properties are in the same column. Each element is identified by its unique atomic number. Each element has a unique chemical symbol that is a 1 or 2 letter abbreviation listed directly below the atomic number on the periodic table. The chemical symbol and the atomic number always go together. Isotopes when the number of neutrons varies. All elements have the same number of protons, but not necessarily the same number of neutrons. Atoms that have the same number of protons but different numbers of neutrons are called isotopes. The sum number of neutrons and protons in an atom is its mass number, is represented by the symbol A. Now, as we said before, here is Z that represents the atomic mass number, and A represents the mass number, and X the chemical symbol. Ions losing and gaining electrons. The number of electrons in a neutral atom is equal to the number of protons in its nucleus. During chemical changes, atoms can lose or gain electrons and become charged particles called ions. The charge of an ion depends on the relative number of protons and electrons as indicated in the upper right corner of the symbol. For example, lithium has no charge, but once you take away an electron, lithium has a positive charge plus 1 electron that could go to another atom, leaving lithium with a positive charge. Ions can also be negatively charged. For example, fluorine plus 1 electron equals fluorine with a negative charge of 1. Positively charged ions are called cations, and negatively charged ions are called anions. Finding patterns in the periodic table. In the periodic table, elements are listed in order of increasing atomic number rather than increasing relative mass. The elements in the periodic table can be broadly categorized as metals, nonmetals, or metalloids. Now, as you can see in this periodic table, the elements that are yellow are all metals, and then your metalloids go in a nice diagonal line separating the metals from the nonmetals, and they are green. And your nonmetals are blue, including hydrogen, which of course is over by the metals. Metals are good conductors of heat and electricity. They are shiny and tend to lose electrons during a chemical change. Nonmetals are solids, liquids, or gases. At room temperature, poor conductors of heat and electricity tend to gain electrons during a chemical change. Metalloids are semiconductors. Main group elements are properties that tend to be largely predictable based on their position in the periodic table. Transition metals are properties that tend to be less predictable based simply on the position in the periodic table. As you can see, the main groups are 1A, 2A, 3A, 4A, 5A, 6A, 7A, and 8A. And your transition metals are right in the middle, and those are all the elements that are very unpredictable and hard to determine what they will do. Family or group is each column within the main group's regions of the periodic table. Elements within a group usually have similar properties. And as you can see, we have all the groups. You have alkyne metals, alkaline earth metals, transition metals, nonmetals, halogens, and noble gases. Noble gases are group AA elements. These elements are mostly unreactive. As you can see, that includes helium, neon, argon, krypton, and it's this beautiful row right here. The pink are your noble gases, and they're very unreactive because all their electron shells are full. Alkyne metals are group 1A elements and are all reactive metals. Alkyne metals, when dropped in water, cause explosions. And 1A is right here. It's all these blue elements, and these are your alkyne metals, and they are very reactive because they have that 1 electron they'd like to get rid of. Alkaline earth metals are group 2A elements and are also fairly reactive, but not quite as reactive as the alkali metals. These elements do not react as vigorously as the alkali earth metals, and they are here in 2A, and they are green. Halogens are 7A group elements and are very reactive nonmetals. These elements are colorful. Cl is greenish yellow gas, bromine is red-brown liquid, and iodine is purple solid, and fluorine is a pale yellow gas. And these are your halogens in the orange column here in 7A. And they are very reactive because they are trying to gain an electron to fill that empty space. Ions in the periodic table. In metals tend to lose electrons, forming cations, and in the same number of electrons to the nearest noble gas. And nonmetals tend to gain electrons, forming an anion with the same number of electrons as the nearest noble gas. As you can see, you have all these elements that have a predictable charge, and then you have all these charges: F7A minus 1, 1A plus 1, A2 plus 2, and so on and so forth. And that's the end of the show, and that's your trends and structures of atoms in the periodic table.